This is Angela, and today we are going to learn about how we can use mathematics to distribute vaccines effectively. It has now been more than a year since the outbreak of the COVID-19 pandemic. Vaccines now exist to combat the virus, but the battle is far from over. Governments and health officials still face the problem of distributing and administering these vaccines quickly and efficiently at the lowest possible cost. Here is where mathematics comes in. Mathematics can help people decide on the best solution to a problem. With the use of linear programming and optimization techniques, we can use the best possible outcome for a given problem. Transportation problem is a special kind of linear programming problem, or LPP, where the goal is to produce products at supply locations or source and transport them to destinations where they are demanded at minimum costs. There are two types of transportation problems: balanced and unbalanced. Balanced is when both supply and demand are equal. Unbalanced is when the supply and demand are not equal. The steps in solving this kind of transportation problem are: 1. First, understand the given problem. 2. Identify the elements to convert it into a linear programming problem. 3. And then solve. There are 3 techniques available to find the initial basic solution: Northwest Corner Cell Method, Least Cost Cell Method or LCCM, Vogel's Approximation Method or VAM. For this video, I shall be focusing only on least cost cell method and Vogel's approximation method for both balanced and unbalanced transportation problems. Let's look at this problem. The Philippines needs a total of 100 million vaccines to be distributed across 3 distribution hubs located in Manila, Cebu, and Davao. Manila needs 50 million, Cebu 30 million, and Davao 20 million. China agrees to supply 50 million vaccines with the shipping cost of $1 to Manila, $2 to Cebu, and $3 to Davao. The US can supply 40 million vaccines at the cost of $5, $6, and $8 to Manila, Cebu, and Davao, respectively, while Russia can send 10 million vaccines at the cost of $4, $7, and $9 to Manila, Cebu, and Davao, respectively. Find the cheapest total transportation cost for the Philippines. From the problem above, we can come up with this table. China, US, and Russia are the supply locations or the source, while Manila, Cebu, and Davao are their destinations. In this problem, we can see that supply equals demand. The Philippines needs 100 million vaccines and the other countries can supply 100 billion. This means that this is a balanced transportation problem. Now, let's start solving using the least cost cell method. According to the least cost cell method, the least cost among all the cells in the table has to be found, which is 1. Now check the supply from that row and demand from that column and allocate the smaller value to the cell. In this table, China can supply 50 million and the demand is also 50 million. Since supply and demand are equal, we allocate 50 million. Next, cancel the row or column whose supply or demand becomes 0 after allocation. Now we have 4 remaining cells. Find the cell with the least cost among the remaining cells. 6 is the least cost among the 4 remaining cells. Now, find the demand and supply for the cell and allocate the smallest number. The demand is 30, while the supply is 40. 30 is smaller than 40, so we allocate 30. 30 minus 30 becomes 0. 40 minus 30 equals 10. Since this column is already 0, we can cancel the whole column. This leaves us with the last 2 cells. 8 is the least cost, so we choose 8. Compare the demand and supply of cell with cost 8. 10 is the supply, while 20 is the demand. 10 is smaller than 20, so we allocate 10. 20 minus 10 equals 10. 10 minus 10 is 0, so the row gets cancelled. Now the only remaining cell is the one with cost 9, and its supply is 10 and demand is 10. Demand and supply are both equal. Allocate it to this cell. 10 minus 10 equals 0, so this cancels the last cell. Now, just multiply the cost of the cell with the respective allocated values and add all of them to get the basic solution, which means it costs $400 to ship 50 million vaccines from China to Manila 30 million vaccines from US to Cebu, 10 million vaccines from US to Davao, and 10 million vaccines from Russia to Davao, using the least cost cell method. Let's try this problem again using the Vogel's approximation method, or VAM for short. In VAM, we need to find the least value and the second least value of each row and subtract them. For the first row, the least value is 1, and the second least value is 2. 2 minus 1 equals 1. That is the row difference. So we write 1 here. In the second row, the least value is 5, and the second least value is 6. 6 minus 5 equals 1. We write 1 again. In the third row, the least value is 4, and the second least value is 7. 7 minus 4 equals 3, so we write 3 in the row difference. We do the same for the columns to find the column difference. For the first column, the least value is 1, and the second least value is 4. 4 minus 1 equals 3. That is the column difference. In the second column, the least value is 2, and the second least value is 6. 6 minus 2 equals 4. We write 4 in the column difference. For the third column, the least value is 3, and the second least value is 8. 8 minus 3 equals 5. We write 5 in the column difference. From the values in the row difference and column difference, we select the biggest number. In this example, we have the numbers 1, 1, 3 for the row difference and 3, 4, 5 for the column difference. Since 5 is the biggest number, we select 5. Now, find the cell with the least cost in the column. Since 3 is the least cost, we allocate the minimum among the supply of the respective row and the demand of the respective column. Demand of 20 is smaller than supply of 50, so we allocate the column's demand of 20 to the cell. 20 minus 20 equals 0. 50 minus 20 equals 30. Since the column is already 0, we can cancel that column. From the remaining cells, find out the row difference and column difference. 2 minus 1 equals 1. 6 minus 5 equals 1. 7 minus 4 equals 3. 4 minus 1 equals 3. 6 minus 2 equals 4. And here is nothing. Again, select the biggest number from the row and column difference. 4 is the biggest number, so we choose 4. From that column, we allocate the cell with the least cost, which is 2. Compare the demand and supply. Since the demand and supply are both 30, we allocate 30. And then cancel the row and column since 30 minus 30 equals 0. Now there's only one column. Since we only have one column left, we no longer need to get the row difference. Select the cell with the least cost and allocate the value. 4 is the least cost. Compare demand and supply. Demand is 50, supply is 10. 10 is smaller than 50, so we allocate 10. 10 minus 10 equals 0. 50 minus 10 equals 40. Since supply of 10 is already 0, we can cancel that row. Now, we only have one cell left, so allocate the remaining demand and supply to the cell. Since supply and demand are both 40, we allocate 40. Cancel out the entire row and column. No balance remains. To find the cost using the Vogel's approximation method, we multiply the allocated value of the cells with their corresponding cell cost and add all to get the final cost. Which means it costs $360 to ship 30 million vaccines from China to Cebu, 20 million vaccines from China to Davao, 40 million vaccines from US to Manila, and 10 million vaccines from Russia to Manila using the Vogel's approximation method. The VAM method gives us a lower cost of $360 compared to the least cost cell method, which would cost the Philippines $400. These examples are for the balanced transportation problems. But what if demand does not equal supply? And, as in the case of COVID-19 vaccines, demand is greater than supply? What if, in our problem, China can only supply 40 million vaccines and the US can only supply 30 million vaccines? This problem now becomes an unbalanced transportation problem, since demand is 100 million vaccines, but the supply is only 80 million. In this type of problem, the concept of a dummy row or a dummy column will be used. As in this case, demand is greater than supply, so a dummy supply row will be added, and the supply of total demand minus total supply will be given to that row. 100 minus 80 equals 20. If the supply would be greater than demand, then a dummy demand column would be added. Since the dummy row would never really be delivered to its destination, then the cost would be 0. Now that the problem has been updated to a balanced transportation problem, it can be solved using the least cost cell method and the VAM method. For this unbalanced transportation problem, it would cost the Philippines the same amount, whether we use the VAM method or the LCCM method. Technology and the use of mathematics can help these officials make quick and accurate decisions on how to distribute and allocate vaccines to the global population. Government officials must enlist the brightest minds in mathematics and science and employ the most powerful technologies to win this fight against COVID-19.